hello. Oh, never mind this. But hello, everyone. And welcome to the Graveyard Club. Have a seat, grab a drink, enjoy the show. And yeah, seems like everything is working. Hopefully, we'll see. And I came back to learn some more. Well, CCNA for networking and stuff like that. So here I am, and let's do this, I guess. We left off because on the last on episode 5th, or this is the 5th episode. Like that was episode 0.
This is episode 5.
Yeah, episode 5. Basically, how a real life Oshi model works. This is where we left off, and I did go into this video a little bit because it was showing me some Wireshark stuff as well, and I needed to install it, and for that to work, I needed to restart my system. So I did. Also, I did ping YouTube here. So this is the IP I need to check. And if I filter this down, this should only show the YouTube stuff. Hopefully. From my local IP, which you can see here too. Is it filtering? I don't know. Ah. IP address, maybe this way. Oh no. Do I need to rerun it for that? I don't know how it happens. We'll see. Anyway, I really don't know how this works. But let's continue where we left off, I guess.
Of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA, CCNP, labs, and practice exams. When you watch a YouTube video, like this one, what happens? What's happening in the network? In this video, we're going to find out. We're going to focus on the upper layers of the OSI model, the application, presentation, session, and transport layers, and see what happens when we try to watch a YouTube video. Let's get started.
Yeah, I want to do this here as well.
Wait, in our last video, Johnny needed coffee bad, and we watched how his internet traffic, his network traffic, would go across a network, across the internet, and get to networkchuck.coffee, where you could place an order for delicious coffee. And it is good, trust me. We dive deep into the OSI model, a model that describes how a network can work. And we watched as Johnny's computer took his application data and threw it down the layers of the OSI model, going from segment to packet to frame, a process we call encapsulation. And then it fired electrical signals, it probably doesn't make that sound, across the physical wire, going
it's
across
electricity,
the network,
basically,
the
somehow.
until it finally arrives at networkchuck.coffee, a server that hosts the website. And here the process is actually reversed, going from frame to packet to segment, a process we call de-encapsulation. And this whole process is amazing. But up until now, we focused hard on the network, data link, and physical layers. We haven't spent much time in the upper layers. Application, presentation, session, and transport. Until now. We're going to look at all that right now. If you've watched the previous videos, you should have a basic understanding of a switch and a router and what it does when internet traffic hits it. If you don't know what that is, then go back and watch those videos. But now we're going up. And Johnny already has his coffee. He's already ready to go. Now he wants to watch some YouTube videos. So we're going to pop the hood a bit and see what happens when Johnny's web browser tries to access YouTube and how the application, presentation, session, and transport layers are involved. You might need some coffee for this. Take Johnny's advice. Let's take a look at the application layer first. So
I don't have a coffee, I will only have simple drink.
To type in youtube.com, and this is where the OSI model comes into play, the application layer. And also keep in mind this does apply to the TCP/IP model, the model we actually use, which is the same as this, except we don't use the presentation and session in that model. But the concept of these layers does not go away in the TCP/IP model, which is why we're going to talk about them right now. And the application layer is kind of the portal, an interface for a program on your computer that needs a network, like your web browser or a video game that you play online. If that application needs to interface with a network, it's going to engage the application layer of the OSI model. It's sort of the gateway to the next two layers, the presentation and session layer. So Johnny's web browser takes the data it wants to send to youtube.com, which in this case would be like, hey, I want to see your site. So it'd be a GET request, get me that stuff. And it sends it down to the presentation layer where we get it prettied up. Time to get it dolled up and ready to go. What does that mean? Well, the presentation layer is responsible for making it presentable. Two of the main things it's going to be worried about is data format and encryption. Now, data format, what does that mean? One way to think about data formats is to think about file types. Let's say I send you a document. It's called mydocument.pdf. When you try to open that document at your computer, what happens? Well, it opens because you've got programs and applications that know how to use PDF documents. That's the data format. Adobe Acrobat, even most browsers can open up PDF documents no problem. It's a common format that we've all agreed to use for things like this. But if I were a weirdo and I put my data in a format that no one even knew about, like .networkchuck, and I sent that to your computer would be like,
what the hell?
I don't know what this is. So that's why we have these file types, these data formats. Things that we all pretty much agreed we're going to put things into this format so we can all kind of play with and read. And with
so basically, basically a file type is should be the presentation layer, but again, we use these three
all the time. HTML. The presentation layer would take our data and put it in a format that we all pretty much understand. Put that to a .html file. And when YouTube does send me a .html file, it knows how to open that. That's what the presentation layer does. So HTML, XML, JPG, a image data type, image data format. That's what the presentation layer does. We can also use encryption at the presentation layer, making sure our data that's being sent back and forth can't be seen by, well, hackers. A common one you might see is SSL, secure socket layer. That's done at the presentation layer. So once the presentation layer is done with our data, he's made it look pretty, putting it into the right format. He may have encrypted it so someone can't see it. We then move on down to session. The job of the session is to open up the communication, to start the conversation between the web browser, Johnny's application here, and the YouTube server, and make sure things have been authenticated, make sure conversation is smooth. Now, keeping in mind, all this stuff is still going through all the other layers.
Where session isn't a clear-cut connection.
The session keeps the communication open. And what I mean by that is that at the lower layers, at the network layer, we're going through routers, the data link layer, we're going through switches. All kinds of crazy stuff is happening down there. But to the session layer, it's one conversation. Let's keep this thing going. And when
well, from my experience with me being a PHP developer, a session isn't a continuous connection. It's just something that both parties remembers that this is my data, this is how you identify me. And it can, when you have a connection, you send this session info, this identification that usually stored in cookies, that this is me, and this is how you can identify me, find my information and stuff like that.
It's done, he tears it down, ending the conversation. And the session layer does this for any communication that the application has with anything else. Maybe it's not just the web browser talking.
But
maybe
yeah, this is on
server. It's managing all those different
application. Well,
it's
up to layers.
See at the session layer are L2TP, or the layer 2 tunneling protocol. You'll see this a lot with VPN connections. We've got RTCP, the remote transport control protocol, which this actually helps set up phone calls. And speaking of phone calls, video calls, the H.245 protocol, which helps set up video calls. And of course, proxies. We have these SOCs, proxies operating at this layer. When you're trying to hide yourself as a hacker or just as a person who values their privacy, you will use a SOCs proxy, which operates at this layer to bounce between different hosts to kind of muddy up who you are. This is not an exhaustive list, but this is one of the most popular protocols you'll see at that session layer. Now at this point, we've covered the application layer and what it does at a high level view. Application presentation session, keeping in mind that all of these are just one layer in the TCP IP model, just the application layer.
Application layer, yes.
We pretty it up, put it in the right format.
Basically what programmers deal with, like myself.
We get the session open. But in order for that session to actually open up, we have to send it down the other layers. And now we're at the transport layer. We're getting somewhere, literally. The transport layer is where people who love networking start to pay attention. Application layer? Nah, that's for programmers. Wait, did you say transport? Now you got my attention. This is where we operate. The session layer sends our data down to the transport.
Basically, what I do day to day is on this application layer, application presentation session layer. And now I'm learning the outer 4 layers.
Transport layer, and now we'll
which is crazy.
Hey, how can we get this data to the other end, to the other server? This is kind of like sending a package to someone. Like, let's say I want to send a package to you. And at the application layer, I'm going, okay, I want to send this, and this cable, this pen, and this coffee mug full of coffee. Then I'm going to put it into a box. I'm going to make it all pretty, tape it together. Okay, done. Now, how do I get it to you? I got to send it to the next layer, which might be shipping. Do I use UPS? Do I use USPS? Do I use FedEx?
How do you send
DHL?
it? Yes,
Who's going to take it for me? What method am I going to choose? How am I going to transport it? Transport layer, see that? And with the transport layer, instead of choosing a shipping carrier, we're going to choose a protocol. There are 2 main transport protocols we focus on. There are others.
TCP and UDP.
Ones we see all the time. We got TCP, probably heard of that guy, and UDP, probably heard of that guy. And at this point, we have to ask ourselves a question. And when I say us, I mean like the web browser or the application. Do we want our data to get there really, really fast? Or do you want it to get there safely and make sure it actually gets there? If we want it fast, that's going to be UDP. If we want to make sure it reliably gets there, it's going to be TCP. Let's take a look at TCP first. Let's say we do want to get our stuff there reliably. The reason it's so reliable is because TCP is kind of naggy. What I mean is that when TCP is communicating, let's say YouTube...
Basically, TCP makes sure that what you're sending arrives there in normal. Arrives there and it is not lost at all. While UDP, just like a machine gun, sends out everything and doesn't care if it lands or not. TCP is like a sniper. He double checks before he's firing. UDP is just a machine gun.
Sends me a file, like an HTML file. Like maybe it's the homepage, so homepage.html. Before it sends me anything else, it waits to see if I got it. It's like, okay, did he get it?
Hey, Akhtar, welcome. Basically, yes, TCP also does arrow checking up. Fucking send it, yes. Well, the arrow checking is basically the one it is making sure if he sent it or not. And it's arrived there in proper format, properly. Like a sniper that makes sure that he can fire it and the land hits the land. After it, he makes sure the land, well, arrived at the target. They basically, the bullet is where it needs to be. And eliminated the target. And UDP is like a machine gun, just press on the trigger and just in the general area. Did he hit the target? Yeah, 20 out of 100. Good enough.
If I don't say anything back, he's like, hey, Johnny, here it is again. Did you get it? And he waits for me to say, yes, YouTube, I got it. And then he'll continue to send me more data. But it's that verification process, that reliability, that makes TCP pretty cool. It makes sure your data is received. And if it doesn't receive a confirmation that you got it, it'll send that sucker again. And another reason that TCP is reliable is that before we even begin to send data to each other, we have to get to know each other first. So YouTube will go, hey,
oh no, it's a different process. Never mind.
I have to make sure we're friends first. Let's do a 3-way handshake. And that's what it's called. The TCP 3-way handshake, which is all about setting up that connection before we start exchanging data, which works like this. YouTube will say, hey, Johnny, how you doing? My name's YouTube, which we'll call a synchronization message. Johnny will respond and say, oh, well, great to meet you, YouTube. This will be our syn ACK message. And then YouTube responds with a ACK, which syn means synchronization, ACK means acknowledgement. And once this formality's out of the way, then they can communicate with each other, but this has to happen. And so this is a bit more involved. Oh, and by the way, TCP stands for Transmission Control Protocol, with a strong emphasis on control because it wants to control every bit of that communication. Whereas UDP, it's a little crazy.
What does UDP stand for?
Do you want to know why UDP is fast? Because it just doesn't care. It doesn't care if you get the message. It doesn't care if you get the package.
It doesn't want to say, huh? UDP. User Datagram Protocol. Huh? That's User Datagram Protocol. With Transmission Control Protocol. In Transmission Control Protocol, it lists in the name what it is. What does User Datagram Protocol mean? What the fuck? Is to send messages, transport as datagrams and packets to other hosts. Yes, why? Why is it so different? Also, why are you not dark? Thank you. Introduced in 1980, and TCP was introduced even before. So again, why? Why the different names? We have UDP Lite. Yeah. Datagram is basic transfer unit associated with packet switch network. Datagrams are typically structured in header and payload sections. Datagrams provide a connectionless communication service across packet switch networks. Well, we already here saw this that here we have a frame, network, a packet, transport is something else. Can't remember what. Oh, segment. It's segment. Transport is segment, network is packet, data link is frame. Ah. It was a user datagram protocol. I mean, just why that name? Anyway, let's continue.
It's a little crazy. Do you want to know why UDP is fast? Because it just doesn't care. It doesn't care if you get the message. It doesn't care if you get the package. It's just going to keep on sending stuff. It doesn't wait for verification. It just goes blah. Here you go. Ah, crap. It just sends. So know how you doing? Nice to meet you. No, YouTube just blah, sends. Doesn't wait for verification. And hopefully
Just say minigun
so now when
or
Johnny's
machine
trying to
gun.
watch a YouTube video, which one is used? TCP or UDP? Both. It's actually using both. Check this out. I'm going to fire up Wireshark, which is a tool we can use to capture our real network traffic.
Yes, I do have Wireshark here.
So watch this. It's awesome. I'm going to start capturing on one of my interfaces here. And look.
And here is mine. Oh. Ah. It does capture.
Look at all that. It's just a ton of stuff. So it's capturing everything. Now I'm going to go off and watch a YouTube video. Let's go. Boom.
And you know what? I'm gonna open a new copy link. I'm gonna do the same as he does. New private one.
This is episode.
Oh, goddamn. Freaking ad.
This is episode.
Oh, thanks.
Alright, let's pause that and let's take a look at Wireshark and see what happened. Let me stop this capture here. Now I captured all my internet traffic and my computer's talking to a lot of things all at once.
Yeah, it's still talking to things. I don't get it why, but might.
Of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check.
And I did ping here YouTube, so I should have it's still, that's the IP. Can see it. That should be the pinging youtube.com. That should be the IP. So what does he do?
So I need to filter that a bit. Now this looks crazy. I know, a lot of stuff going on, but we'll break.
Okay. He uses a different IP, but let's try. Stop. So IP dot address, and I want to use this one. And we found some. Nice. I have no books. Honestly, all I have is this playlist. That's all I have. Also, would have soon a router with OpenVRT installed. OpenVRT installed, and probably a few Raspberry Pis as well. So I can test out shit on a more closer level. But yeah, here are some stuff that we captured. Quite nice. Here it is, the first one coming in. No. This is not coming. I'm going out to get to YouTube on TCP protocol. Synchronization request. Sure. Todd Lame. And free it's and latest books. These ones. Well, one of them, I guess. I guess I'm gonna need this one. Honestly, I am learning this so I can create my own little network stuff. So I can understand it better. So I don't screw up too much. Because I already tried to create a network, but I managed to, well, screw it up pretty badly. I needed to revert everything because I had zero idea what I'm doing. I did, or how should I even approach it. That's why I'm learning this, so I have at least a little bit of an idea how I should approach it. Because my next question is, this is great, a program, but do I have this on? Yeah, I might not need it. Hey, if everything is working out, I might even do the whole exam as well. I might need it because having a certificate under my belt, just it's a extra for me. What are you doing crypto here for, huh? I know it's just encrypting, but just saying the word crypto is just yeah. What there are QEC. Is a frame packet. But yeah, this is gonna be useful for me later on. Especially, I also saw this CompTIA Network Plus thing, which is a different network certification. But what I understand, it's a different type. Yeah. Yeah, I read this as well. CCNA is more Cisco specific, but well, they have Cisco is most majority of the networks that runs, to my knowledge. Yeah.
Down just a few things here. First of all, this IP address right here, 173.194.191.167, that is the IP address of YouTube. So when I open up my web browser and I
it's not URL, the same IP for me.
Going to. Notice the source is my IP address right here, destination is YouTube, and look at the protocol.
And the source is my local LAN IP, because even he's the local LAN IP, because it starts with 10, that should be a local IP. I think there's two local IP networks, 192 and 10, right? Two local IP range. 3 reserved IP addresses. Yeah, private network. Oh, right. 172 as well. But that's usually for local network only. Wait, what? Yeah. And the 10 private network. Huh? Bigger subnets. Oh. Wait, what? Ah, right here. I was like, why is this different range here? Like for some reason, yeah, I understand that some net. I was more about IP because I was under the impression that the whole 192 was for private network. And then here is this. And then, yeah, that's understandable. Yeah. No, it's not understandable because, again, what the hell is this? Why is this reserved? Yeah, I get it. It's reserved for something, but why in the middle of the private network stuff? And that this whole is just all over the place. Because again, this is a lot of numbers of current local this network. Yet again, nobody uses this. Or does it? Because if I try to ping this, ping 0.0.0.0, but I do understand that because this is this local machine. This number is always the local machine. Yet the whole subnet, the whole this thing is just assigned for the whole machine. That's 60 million addresses just for one machine, your local machine. Yeah, I get that. There's a lot of strange IP addresses. One of them is this one. Like, why? Why does one machine that always gonna refer to itself need 60 million? Why? And yeah, 10 million is again private network for a large private network. And this is the default, usually the 168.168.0.0.0 is the default local network. Because even my router uses that. And yeah, I know that as well. And some people use this as well for home labs and stuff like that. Even though this is more than enough for most people because you won't have this many devices. But it can confuse some intruders as well. Seems like we have IPv6 reserved as well, which, hey, at least in IPv6 they fixed it. Localhost only has one IP. They fixed it. Amazing. They fixed it. And use a software. And private internet. Global internet. Which one is private network? Maybe it's this one, the IP format, but so it uses both. Or link to local address. I don't even remember all. I remember is how much I.
Wow.
Hey, Lex.
You must really like me. Like me.
Reading IPv6 must be like. Yes, pretty much. FC00, I think. Private internet? Sure. Yeah, I can. Ah, yes, here it is. Unique local addresses is an Internet Protocol version 6 address in the address 3. Yeah, you are right. That is the local one. Hey, Lex, welcome to the Graveyard Club. Have a seat, grab a drink, enjoy the show. Of me learning how this whole thing works.
Mission control protocol, reliability. And notice here's a three-way handshake right here. Got my SYN, my hello, how you doing? My SYN act from YouTube. I'm doing fine on YouTube. And then the act from me. And then of course a lot more stuff going on down here. But I want to scroll down.
There's a lot of things.
I said we're using both, and I wasn't lying to you. If you scroll down a bit, I mean, there's a lot of things going on. We'll keep scrolling until I finally made it here. Okay, cool.
What we are not using?
TCP,
okay.
And it changed everything to UDP.
We are not using UDP, but QIC. Also, Lex, I think I forgot to thank you, but thank you for the subscription. And QIC is something that Google made, to my knowledge. Yeah, Quick. It's called Quick, not QIC. It's Quick. The general purpose transport layer network protocol designed by Jim Roskin at Google. Yeah, it was first implemented. Yes. Yeah. Huh? Quick improves performance of the connection-oriented web applications that previously relied on TCP. It does this by establishing a number of multiplexed connections between two endpoints using user datagram protocol. And it's designed to obsolete TCP transport layer for many. Basically, are you saying this is a connected UDP? If I understand it right. I don't think it's gonna be. It might be a part of it, might not be, because again, there's RFCs and norm layer UDP. Well, But yeah, Google uses Quick here instead of, well, UDP. So we got some payload here, which probably is chocolate. Thank you. I don't care about outdated stuff. But we have the initial TCP connections. That yes, this is YouTube. I am myself. Then we go TLS. Yes, then we go application data, acknowledge. And here is we just switch over for some reason. And we can see bytes here, but yeah, I have zero idea what this even means. So I'm not gonna even attempt it to understand it. But here is quick, I guess this is how the initial handshake and every connection goes. Oh yeah.
Still talking to YouTube. It's still me talking to YouTube right here. But the protocol switched over to UDP. Why? Well, when Johnny sent his request to watch a YouTube video, and obviously I'm changing myself to Johnny now, YouTube doesn't just send a video, but it sends a web page as well. So like we look back at the web page here. It's loading all kinds of stuff, like we got the menu right here, we got suggested videos.
Yeah, those are
here,
all different
sign-in stuff,
requests.
buttons, graphics, all kinds of stuff. This is all just a regular web page. In fact, if we look at the developer tools, which you can do in any web browser, we can see that it is indeed an HTML document. So YouTube sends the HTML file and along with other stuff to build out this web page.
As well.
But then it starts to play the video. This is when it switches from TCP to UDP to send data. But why does that video need UDP?
Well, for us, it's
why
quick
can't
now.
Use TCP? I mean, what's wrong with having reliable transportation for a video? Well, think about when you're watching a video, like let's say this video right now. With UDP, you're just getting this data. Bam, 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 bam. The video's coming at you. You might miss a few of those packets. So let's do a clip, for example. Let's say I go, that is delicious coffee. But maybe your internet connection's bad and you drop a few packets. So it might look like this. There's coffee. Now that's not great because you missed something. So you might think, well, we can prevent this from happening by using TCP, right? It'll make sure you get stuff. It sounds good in theory, but here's what would happen. There's coffee. That is delicious. You see, for real-time applications.
Yeah, he just said it a real-time application. If you watch it as it loads, then yes, this problem occurs. But if you download it, then TCP is better because it will put it in the correct order then.
Applications like that.
With UDP, you're not so sure about
watching a video, watching a live stream, gaming online. It doesn't make sense to resend the same thing because once that thing's missed, it does no good to get it later. I mean, this has happened to you before, right? Like you're playing an online game, you're running, maybe your internet connection drops for a second, and you're suddenly 15 feet ahead. It would make zero sense to try and have that data sent back to you and throw you back 15 steps so you could walk that hallway. No, you'd already be dead because someone shot you up there. So TCP is great and it's used for most things that don't require that real-time interaction, but when we need to have things quickly and fast, and we're retransmitting things which would not make sense, that's where UDP comes in. Now there's one more thing I want to touch on with the transport layer in TCP and UDP, and it's these numbers right here. 443 and then 57095.
Those are the port numbers. Even I have these here. That we're sending from, well, a random port to 443, which is the basic HTTPS port. And we get it back as well. And yeah.
They're crazy important, but what are they? Let me show you a problem we might have if we didn't have those numbers, which we call ports, but we'll cover what those are in a minute. When we want to watch a YouTube video, we have to access their server, which means we have to go over the internet and hit their IP address. This will be using the HTTP protocol, and in pretty much all cases now, the HTTPS for secure protocol. But what if that YouTube server wasn't just doing a website? What if it also had FTP, a file transfer protocol server? What if it had SSH and RDP? Both protocols that we can use to access a server remotely. So if I wanted to SSH and log into the command line of that YouTube server, how do I tell it that? How do I go to the IP address and say, I want to SSH and not just I want to watch a video? That is what those port numbers are for. If we look back at Wireshark where we captured our network traffic, look at this first message, which is from me to the YouTube server. I'm using the TCP protocol, and here's the from port. We'll talk about that here in a moment, but the to port is 443. You may already know
they have a
that
different
443
from,
is the port
but the to port is the same.
commonly used for HTTPS. So in your web browser, when you type in https youtube.com, you're saying you want to access this server IP address on port 443. It could also look like this, the IP address with a colon after that and the port. So I want to access that server, that IP address, on port 443. Those ports allow us to run multiple services on one server. So one server can be a ton of things. It could be...
Basically, as I say, ports are doors that can be opened or locked, in my sense. And one IP can have lots of ports. How many ports? Wait, what? How many ports are there? Let's see. IP ports. I don't know why it's in Hungarian. Wait. These are the reserved ones. The script is assigned by ENvtuber port in standards. I specify the values for such. Free to use ports, you can map the free to use ports to any other ports you want. Port translation. The script protocol is not assigned by ENvtuber, but is standardized. Assigned. The script protocol is assigned by ENvtuber, but it is not standardized. Not standardized, not used, reserved, port reserved by intent assigned number authority. Generally, to prevent collision having to its previous use removed, the port number may be available for assignment upon request to INO. So 0 is reserved. In program API is not in communication between us. Dynamic ports. Alright, Akhtarboss, thank you for being here. And bye-bye. TCP port service. Remote job entry. Echo protocol. TTP. What is S? Stream control transmission protocol. And DHCP. Discord per Vcon. Vcon LAN. Unofficial. Active users. I know 2022 is SQL Shell SSH. And he's 2021 is FTP. LMTP, SMTP 25. NSFFE, not safe. What is, I don't know. I don't know why NSFE comes here, but here it is. Display support time protocol. REP, root access protocol. NSF. Now, WIS protocol. There's a lot. DNS is 53. We have 80 hyper at the HTTP for. Herbrus is on assigned. Okay. DCP. There is a lot. Post office protocol, POP3, POP2. Huh. NTP. There is quite a lot. IMAP3, MPP. Ah. So I'm just reading off protocols that I remember using or just, you know, having seen it in my developer time. Is 443 Hypertext Transfer Protocol secure using SSL and HTTP uses quick. Oh, HTTP uses TCP in version 1 and 2 and HTTP 3 uses quick. Oh. Active Directory. Remote shell. But yeah, I guess the first 1000 is pretty much reserved. Range of port numbering 4 are to register TR assigned even for special service upon application by request entity. On most systems, registered ports can be used without super user privilege. Yeah. Basically, this can be used however you want. It's just some softwares do use this. Civilization 4 multiplayer. cPanel. Armam Halo Combat app. Yes. Some all these but goodies. Jesus Christ, this is a huge list. Ports containing different port private ports that cannot be registered. Ah yes, because there's so many ports. This 65,535. Verica ports. Okay. WireGuard protocol. BitTorrent. Okay. Back to the video.
RDP server, SSH server, FTP server, web server, gaming server. You can open up other ports, other windows into your server. And no, I'm not talking about Windows Server. It could be Linux, I don't know. Another well-known port you might know about is port 21. Port 21 is commonly used as FTP, SSH 22, RDP 3389. If you go to Google and just type in common ports, you'll get a ton of information. I'll give this Wikipedia article real quick.
Yeah, I just watched.
Notice we have our port numbers here in one column, and then we have TCP and UDP. Some ports are only TCP.
Again, he doesn't have this HTTP and stuff like that, which is interesting. So what are those protocols? Because those are protocols again, but what kind? Stream Control Transmission Protocol is a computer networking communication protocol and transport layer of the Internet Protocol suite. Hey Moon, welcome to the Graveyard Club. Have a seat. Grab a drink, enjoy the show. I am learning as well, don't worry. I am just learning about all these protocols and shit like that, but mostly about the networking stuff. Originally intended for Signal System 7, message transport and telecommunication, the protocol provides a message-oriented feature of the user datagram protocol, but ensuring reliable in-sequence transport of messages with congestion control like transmission control protocol. Unlike ODP and TCP, the protocol supports multi-homing and redundant paths to increase resilience and reliability. Not bad. And what about datagram congestion control protocol? The machine or transfer layer. TCP implements reliable connections to tear down explicit congestion, notification, congestion. Hey, Monyo, welcome. Welcome to the Graveyard Club. Have a seat, grab a drink, enjoy the show. I am just learning some CCNA stuff. So what I'm understanding is kind of like something that come so that getting new messages. If I understand it correctly, Stream Control Transmission Protocol kinda can replace TCP, and Datagram Congestion Control Protocol can replace UDP. NaGeL, do you know anything about copyright for releasing covers? Well, usually you have to contact the one who made the song and get explicit permission from them, but usually for covers they do give that out. If you have explicit permission, then there should be no issue. But usually they don't make a fuss about covers, so there shouldn't be an issue. I hope it's not.
UDP or can use either or. And notice this is.
Well, I don't. They're quite a big band. Well, then I don't think it's gonna be an issue then. If it's you again about covers, they don't make issue out of it usually. But I'm not the right guy to ask about it, honestly.
Scroll down, there are a ton, just a ton. In fact, we have available ports 0 through 65,535. But as far as these well-known ports, which are listed below,
I mean, it's not for me, of course.
23 are reserved for those. Now,
yeah.
All of them, but it is important to learn the key ports.
Good luck, though.
Ports that you'll see used a lot. So 22 for SSH, 23 for Telnet, 25 for SNMTP, port 80 for HTTP, 115 for SMTP, 123 for NTP. So just a lot of stuff out there. So looking back at Wireshark, we got this destination port of 443. We know what that's for. It's for HTTPS. We're accessing the web server of YouTube. Awesome.
Yeah.
But then what's this big number over here? 57,095? Obviously not part of the
different for us, but it's
well, network communication is a two-way street. So when I'm communicating with YouTube and I'm saying, hey, I want to access your web server, I want to see some videos right now, that's going to send that video back to me. That's going to send that video back to my IP address, which if I'm only accessing YouTube, that's fine. But I'm not only watching YouTube right now. Often I'm listening to Spotify, so Spotify's sending me stuff too. I'm browsing a few other websites at the same time. I mean, we all have like a million tabs open, right? So they're sending me data at the same time. I'm receiving a lot of data from a lot of different network applications. So that port number, 57,095, is kind of like my from address. When I say, hey, YouTube, send me back a video, I say, hey, send it back to me on this port so my application can get it. Because I'm doing a lot of other stuff right now. You're not the only application I'm talking to you. Sorry, YouTube. So essentially, my web browser pulled this number out of the air. It's temporary, often referred to as an ephemeral port. I love saying that word, ephemeral. Say it, ephemeral. Say it out loud.
Ephemeral. Am I saying it right? Ephemeral? Ephemeral. Hey, Levi! Welcome. Thank you for the alert. Ephemeral. Am I saying it? Ephemeral. Pronunciation.
Ephemeral.
Congrats on your free brain cell, Levi.
Ephemeral.
Zombi egészségidő.
Thank you for that.
Right now, ephemeral. It's temporary. And when YouTube sends me that video, it responds back to that port, my IP address with that port. If I look back at Wireshark and I stop filtering just by YouTube traffic and I look at everything I'm talking to right now, you can see that my computer is using a bunch of different source ports. 52015 for this particular server I'm talking to. 51931 talking to this server. And here's an example of the server talking back to me on my port. So 443 talking back to my ephemeral port here. So let's walk back through what just happened with YouTube. Let me
There's lots of TCP
communication with
connections.
YouTube used both TCP and UDP.
Here's some
The
UDP.
application layer got it all pretty and ready for me, boxed up with a bow on it. My web browser decided to use TCP on port 443, and we take that information, that segment, and give it to the network layer. And what does he do? Well, he handles the IP addresses. So now it
Question is, can I do that from the shell? Wireshark. Shell. You can. Nice. Sorry. So if I just start Wireshark, what Wireshark? Wait, what? Didn't I? I did install Wireshark. Yeah, I downloaded this one with installer and all that. Documentation. Command line manual pages. Why isn't Wireshark in this? The hell? Nope. Wireshark.exe. Nope. Something Wireshark program for the Windows systems. I have zero idea where Wireshark is. And file location. Properties. See programs of Wireshark.exe. So let's go over cdc program files. We have Wireshark. Here is the Wireshark. And we have a Wireshark.exe, right? Wireshark.exe. I no blah 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 blah. I need in command line, please. There are some command line. Wait. Wireshark Windows CLE. Yeah. I need something else. Because then they shark then, I guess. Yeah, I need this, I guess. The fuck? Then we have a T sharky, right? T. Ah, I guess we need this one, right? So, if we're checking T shark, capture interface, right? Capture filter. I have zero idea what those do. Where from two personalities? Uh-huh. User buffer, bearing, buffer, capture packet, list interfaces. So, big D. We have Ethernet, that's what we need. Device, whatever this is. For each network, a number and an interface and possible followed by text description of the interface printed. The interface name or the number can be supplied to the I flag. Yes. So T shark I2. And it captures everything. Wow. Beautiful. Now I need to somehow filter it. Yeah. Read Twitter. Choose a sync to read display filter rather than capture filter. Okay, I still need to filter it this somehow. Okay, I guess I need the capture filter. So F. Capture filter. Set the capture filter expression. This option can occur multiple times. Used before the first occurrence of the I option, it sets default capture filter expression. Used after I option, it sets the capture filter expression for the interface specified by the last I option occurring before this option. The capture filter expression is not set specifically. The default capture filter expression is used if provided. So for example, if I want to filter it to, well, YouTube, again, let me ping YouTube again. Ping YouTube. Interface that. And IP address, I guess. Am I doing that right? Filter expression. How does a filter expression look like? Syntax of capture is by the pcapdry. Okay. What the hell is that? And pcap. This is what is installed for me. Yeah, this is what I need. I need you, baby. Filters. Pickup filter, yes. I have zero understanding of this. Yay. Filter expression consists of one or more primitives. Protocol. Yes. IP. Mm-hmm. protocol RPP, P6R, all different directions. Ether proto IP. Host number may be Ether address or name. If it's IPv6, it may be spot 0. Yes. If I understand it right, I can IP hostname. No. I don't think I can use domain names here. I have zero idea how any of this works. Yay! So, T-Shark. Filter. Capture pings or TCP traffic on port use ITP or TCP port. Capture use display. By comparing display fields are more versatile and can be used to select expert info that can be determined with multiple analysis. For example, if you want to see all pings that didn't get a response station. BFPP. See how dumb cap. What the fuck is that again? There is so many things I am not understanding here. I guess it uses different stuff. Let's try TCP port 80. Anything else I don't care. Holy fucking shit, that's a lot. And what if I want an outbound one? So I guess I do need to use this. I have What the fuck is this? But I guess, can I specify? Man, I have zero idea what the fuck I'm doing. Please help me because Jesus Christ. Yeah, wait, that is IP source maybe. If I say IP SRC and I say this. Why? Oh, for fuck's sake. But why? Why isn't this a valid one? Name must be reserved at least IP for address for ARP host, IP host, or RAP host. But why is it so much harder? Oh, yeah, T-Shark help. Start here, insertion. Yeah, it's installed there. So I want to capture with T-Shark. And I need filters. Just unlock fire display capture use per click packet with. Here are favorite. Capture only traffic to or from specific IP addresses. It uses host. Okay. Host. Examine. Ether proto ARP, Ether proto ERP. So whatever proto of the Ethernet header is ARP, the source or destination host of ARP header is or. Aha. Okay. So if I say host that, anything it captures should only be from YouTube, right?
Legjobb kaja? Check. Legjobb barátok? Check. Legjobb progi? Odaáll.
Yeah. Fucking ads. What it's working?
This is episode 4 of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA.
What I don't see weak. I see a lot of TCP, but no author protocol, which is kind of strange. And no author protocol. Enough. Can I try to filter to protocol? Specific IP address or two from addresses, or two from sources or the range of IPs. MAC address, capture only VLAN traffic. Wait, I can use host. Capture all traffic in specific packets. Port range. So if I say not IP but www.youtube.com, anything coming from YouTube would be captured now.
CCNP, labs, and
Feels quick.
TCP/IP, and OSI. Networking models that define how we connect our computers.
Why we
Without
different
these, we wouldn't
IP
have
then?
networking. So in this video, we're going to watch
Yeah.
it happen. We're going to follow a packet as it goes through a network and how it interacts with each layer. Let's do it.
Interesting. Anyway, back to the
It looks
original
like
video.
this at this point. We have our data from the application layer. We have our layer 4 header from the transport layer, which basically is saying we're using TCP port 443. And the network layer is going to slap on a layer 3 header, turning this into a packet. And it's got a destination IP address of 1.
Question. Does OpenVRT have Wireshark? T-Shark? OpenVRT Wireshark. Oh, now to capture filter insert packet use TCD or Wireshark tools. Yes, this is what I need. So it is possible. Okay, perfect.
73.194.191.167. blah, blah. Kind of hard to see there. You know what it is. And then it goes on down. You know the process. If you go back and watch our previous videos, you know what happens. Oh, and of course, this layer 4 header also has the source port, of 57095. And when it goes through the internet and finally arrives at the YouTube server and it gets to the transport layer will go, oh, hey, this is coming in on port 443. This is our web server. Let me hit this up to the web server application. All right, quiz time. Hope you're ready. Hope you have your coffee ready because this is gonna make you think. These questions are brought to you by Boson XM, the best practice exam software out there for any kind of Cisco, CCNA prep, CCNP prep. So if you're getting ready for your exam, you might want to get Boson and see if you're ready. But let's see how you're doing right now. This will be a simulator question very similar to what you might see on the exam, so I'll go ahead and launch this right now. Ooh, look at this. So select the application layer protocols on the left and drag them to the corresponding transport layer protocols. All application layer protocols will be used.
HTTP is TCP, that's for sure. SMTP, I don't know.
So I know you can't drag this with me, but write it out on a piece of paper and see what you got. Oh, and I realized that we did not talk about every single protocol here. Go research it, go figure it out. If you already know it, that's fantastic. This is your chance to learn it right now. So let's see what I know right now. DNS, that's going to be TCP and UDP. It uses both. DHCP will be UDP.
Really?
Port number? Let me know in the comments below. FTP, that's going to be TCP. What was that again?
Yes.
Port number, 21. HTTP, that's going to be
TCP 80.
SMTP, it's going to be TCP.
TCP.
SNMP, UDP, TFTP, UDP. I would love to see you put all the port numbers to these protocols in the comments below. Let's see if I got it right. Let's show the answer here. Yeah, we got it.
So did somebody do that? Yeah, here it is. DHCP, Dynamic Host Protocol. Wait, what? Simple Mail Transfer Protocol, yes. SNM. Simple Network Management. HTTP Hypertext Transfer Protocol. TFTP. Okay.
Right. All right, second and final question. Which of the following ports is used by TFTP? Select.
Well, we just said it's
the best answer.
TCP.
And you would already know the protocol from the previous question, but you don't know the port number just yet. Let's see what you got.
So 69.
Right, time to see if I know this.
Because 21 and F20 is used by FTP.
And I know it's going to be UDP port 69. Let's see if I got my answer right. And
yes.
Correct, I got it. If you got both of those questions right, congrats. That's amazing. Like, this is from Boson XM, the CCNA practice exam. It's the gold standard. If you can pass their stuff, you're in a pretty good spot. Many people say this is harder than the actual CCNA exam. Today we covered a lot. We saw how Johnny, when he wants to watch a YouTube video, what that looks like from the OSI model or the TCP IP model perspective.
Let's check the next one. And after that, I might go play some games. Why would you do that?
Okay, what about a baby? If you can't afford to lose one link or one switch or one router, you're doing it wrong. In this video, I'm going to show you two network architectures that can help make our networks awesome. And a huge, massive shout out to Boson Software. They are the official sponsor of this free CCNA series. And if you're trying to get your CCNA, which I assume is probably a lot of you, Boson has the best labs, practice exams, and now the best courseware you can find for the CCNA. I'm actually giving away 3 copies of their courseware and labs in the link below, so enter that contest. It ends tomorrow, Friday, so hurry up. Now, before I show you what a good network design looks like, just a beautiful, delicious one, let me show you a bad one first. As you're working towards becoming a network engineer, you're gonna see some bad networks. And it's your job to identify why they're bad and how you can make it good. Now, to find a bad network, you don't have to look very far. Look in your house. I'm not kidding, your home network sucks.
Yes,
I know a lot of you probably
it's a single point of failure.
Comment below with what you have. But for a lot of you, if you ran a business out of your house and you use that home network, it just die. Your business would be dead. Now, I say that because a lot of businesses, when they first start out, their network looks very similar to a home network, and they make some big boo-boos, some very big mistakes. Let me show you what it might look like. So, Network Chuck Coffee, still a very young, small, growing coffee company. And let's say I trusted a noob to install my network. I would never do that. But let's say I did. Very similar to your home network, I'll have a router. Although in your home network, your router isn't just your router, it's also your switch, your modem, even your WAP. No, not the song, a wireless access point. This is a networking video, get your head straight.
Yes.
So it's doing a lot, which is a horrible thing. You don't want to have one device doing everything. And we'll get into why that's important here in a moment. But for now, my coffee company just has the router, and my router connects to a switch. And honestly, for a small business, this is fine. I've got my computers connected to my switch. I'll have a WAP, the wireless access point, connected to it as well, giving me Wi-Fi to all my people, maybe a few phones, and then of course my server to run my website. Well, hold on a second. My switch only has 24 ports.
Hey,
I'm out of
traveler,
ports. I have more
welcome,
things to connect,
welcome.
more computers.
I'm just learning some CCNA stuff, some networking stuff. Because I want to create not a home lab, but something similar for my friend. And I need to learn. Welcome to the Graveyard Club. Have a seat. Grab a drink, enjoy the show. How are you?
There's more servers. What do? Well, I tell my noob network engineer to fix it for me. And this is where the noob really screws up. What does he do? Well, he gets another switch. It's fine. He does a great job getting that. Here it comes. And then he connects the switch to the switch. And then, hold on. What did you do? Hold on. What did you do? This is bad. I'll explain why here in a moment. And before long, I'm growing like crazy. So I need to add another switch. So my noob network engineer does another switch, and he adds it out here, and then he does it again. He connects this switch to that switch.
Why?
Ooh, I'm sure a lot of you, if you know networking, this is probably scaring you. It makes me just have heart palpitations just thinking about it.
No,
this is bad.
For me, it's just why. Why have a single point of failure when you can connect it to the other router? And I guess a router has the DHCP server, the one that allocates the IP addresses as well.
Now, it works. Don't get me wrong. This totally works. But then this happens.
And yeah, I have a lot of learning to do, and you're doing all right.
Then suddenly,
that's good to hear.
The cable breaks. And then what happens? Well, all the devices connected to this switch and this switch, they're gone. They can't connect to anything, right? They're down. This right here is what we call, now say it with me, a single point of failure. Don't ever have those in your network.
I said it. It's a single point of failure. I said that. And I am alright, just all over the place. And just learning some things. Work is work.
Ever. All of these right here are single points of failure, which basically means if one thing fails, then most of your stuff goes down. Never want to have that. Now again, this design still works. You might have something like this in your house. There are a lot of businesses that have this, and it works most of the time until something fails. In your home, you can afford it to fail because the worst thing that can happen is you miss an episode of Netflix, or worse, you can't watch my next video, whatever. But in business, that means dollars and cents. That's money, time. Now I'm showing you this because you will see this in the...
And that's what I screwed up with my friend's place, because the single point of failure was the router itself. And that crapped itself. And why only have one point of failure when you can have every point of failure? I mean, it's possible.
In the real world. And you have to tell them why it's dumb. And you have to fix it. So how do we fix this? What do we do? Well, some might think, well, we have those single points of failure. Let's just add another connection. We could do that.
No.
Add another cable here. Another cable here. That's better, but what if the switch goes down? What if this switch goes down? We still have glaring problems, and this is not ideal, which is why we have two designs I'm going to talk about today. It'll help us become redundant, and you'll hear that word a lot when you're talking about network design. You want to remove as many single points of failure as you can, so you want to be able to have a cable go down, but things still be up. A switch goes down, but things still be up. Let me show you what that looks like. So daisy chaining our switches together? Bad. Don't do that. So what do we do? How can we make this better? Well, we can do this. Watch. Let's put the router right here. Instead of daisy chaining, we just connect our switches to the router. Each one.
Yeah, that's what I said.
That was easy.
Connect it to the router, and that's it.
You're making it sound so hard. Well, we're not quite done. Now, this will work, but it's not ideal. So, for example, my computers. This works great for when they want to get to the internet, because that's what the router is great for. Layer 3. Yes. But my computers and my servers aren't just talking to the internet. They're talking to each other. They're talking on the same network. And that's where the router becomes less ideal, and he's not the best.
Then connect the switches as well.
What we want is another switch, but not just any switch. Oh, you're going to love this. This is something, when I found this out, I'm like, mind blown. So we're going to scooch the router up here for a moment. He's still in play, but we're going to talk about something else here. We're going to bring in this guy right here.
What is that? Fuck is that?
It's a switch.
It's a chaos. It's chaos sign. It's chaos from 40K. Chaos.
But it's not just any switch. This, my friends, is a multi-layer switch, often referred to as a layer 3 switch, which might sound weird if you've watched my previous videos. We know that switches, they deal with layer 2 MAC addresses, and routers deal with layer 3 IP addresses. What's a layer 3 switch doing here? That's sci-fi, that's weird, I can't deal with that. No, it's amazing. It's literally a switch that can deal with IP addresses and MAC addresses. It can do it all, and it's blazing fast. And then our multi-layer switch will connect to our router, and we're looking a bit better right now, aren't we? I mean, it's really beautiful.
But then again, a single point of failure. If the multi-layer switch dies, everything else dies.
If the switch goes down, then these two are still up. This computer's still up. This server's still up. It's better, right? And I'm sure you're thinking, well, Chuck, we still have this right here. This is point of failure. Yeah, we'll get to that. We're taking baby steps, and you'll encounter this a lot when you design networks for businesses, because designing a network with...
Okay, multi-layer switch. What the fuck is that? Multi-layer switch. This MLS. The switches on OSI layer 2, like on the network, to improve extra function on higher OSI layers. Okay, and how does it look like? Chaos, I can do anything, pretty much. Wait, I just... Is this for free? Holy fuck, this might be for free. Forget calling multi-layer, it should be called JaVeil switch. Why JaVeil? Wait, which device separates collision domain per port? Which, right? Yeah. Which term means useful data after protocol overhead is removed? Good put. Yes. I didn't play that, Tarun. What is the correct order of the TCP three-way handshake? Sin, act, ek. MTU refers to... I have 0. Maximum transmission unit size. I guess. Wait. Yes. Which OC layer provides end-to-end transport and port? That transport. What device brings a broadcast domain? A router? Yes. Choose the correct encapsulation order from top data to bottom bits when sending data. Maybe this is way better now. Data segment packet frame bits, yes. Which statement about UDP is true? UDP is no, UDP is gonna... UDP is connectionless and does not guarantee it. In Cisco CML Labs, how do you inspect packet headers and encapsulation? Use IP route only. No? Okay, Wireshark. I didn't think I needed Wireshark for this, but oh well. Which metric measures the time it takes from packet to travel from source to destination? Latency. Which layer adds source and destination MAC address to frame? That's layer 2. Because it is the hint frame. Which one is an application layer protocol? HTTP. Which device primarily operates at OSI layer 2 switch? How many bytes long is a standard Ethernet MAC address? How many bytes? 16, I guess? No. Then it's 8 bytes. No. 6 bytes. Ah. Or preserve which pair? IP to MAC address. Which field detects the frame corruption at Ethernet? Frame check sequence. Which EP4 header fields prevents packets looping forever? TTL, time to live. What is the default TCP port for HTTP? 80. On 802.1q VLAN tag is added at which layer? Network layer, I guess? No. Then data link. Which layer is responsible for routing using IP addresses? Data link, no. Network. Finish. Oh well, I am going to save this one because this is quite useful.
Limited single points of failure can be...
Right, back to the multi-layered switch. We have layer 4 switch as well. No. You know what? Never mind. Let's go with the video.
Crazy expensive. The more devices you add, the more the bill goes up. So I'll show you how we can fix this single point of failure here in a moment, but just know the more we add, the more it costs. You'll have to work with the business and what their budget is. Now this architecture, this model here, the way we designed our network is called a 2-tier architecture. Let me show you the tiers right now. Here's tier number 1 and tier number 2. The switches in this tier 1 are called our access switches, and we'll call this layer our access layer because they give our devices, the things we connect to our switches, you know.
Access.
Where'd my cables go? Hold on. Things like Raspberry Pis, giving them access. Ooh, that sound. Let me add a Pi in there real quick. Can't not have a Pi, Raspberry Pi in my network here. What am I, crazy? There we go, much better. And then our tier 2 layer, this guy is called our distribution layer. And of course, this would be our distribution switch. Why is he called that? Well, because his job is to distribute all the packets, all the frames throughout the network. Like, he's it. Everything goes through him. If the computer wants to talk to my server, well, the computer goes access switch, distribution switch, down to access switch, down to server. If he wants to access the internet, access switch, distribution switch. Router. Now, because everything goes through him, he's got to be pretty bulky. He's got to be
Strong.
He's got to be big. Now, what do I mean by that? Well, think about computers. This Raspberry Pi, while he's awesome, he's not like a computing powerhouse. He's tiny. You're not going to be playing Call of Duty on this guy. Well, not yet. Yeah. You never know. He's not powerful enough. And the same goes with switches. If you got a tiny little 8-port switch, he can only handle so much traffic before he's like, I need help. So don't put a tiny little 8-port switch in your distribution layer. He'll die. So in the distribution layer, you'll want a massive switch with a lot of horsepower. And just like a computer, it'll have more components, more expensive hardware to make it faster. Now, I've shown you access layer switches. It's something like this. But distribution layer switches are a whole other beast. Emphasis on beast. Let me show you one real quick. Here are a list of Cisco switches that could be considered distribution layer switches. And you've got options. And it all depends on what you need and really how much you need.
Jesus
Like right here, we have the
Christ.
Cisco Catalyst 3850s. They have a very similar form factor to the access layer switches, but they can handle a lot more. Like look here, 480 gigabits per second on their backplane, which means they can handle that much traffic going through them at once, which is a lot. But of course, if you need more, you can get more. You go up to the Cisco Catalyst 65.
Terabits per second. Look at this. Terabits per second.
500, you got 11.4 terabytes per second, or terabits per second. And look at that thing. It's crazy. Look at that guy. And we'll cover more about these guys here in a moment, because they can go bigger and they have a different role. We'll touch on that here in a moment. Now, we haven't gone too deep down the Cisco rabbit hole just yet. We will, don't worry. So I kind of glossed over what the distribution layer is responsible for. It does more than just distribute. Like, let's take a field trip over to the Boson courseware real quick. You'll want to get this stuff. I've got their courseware open. Now let's learn about the distribution layer real quick. If you want to get this, I got a link below. Now, I didn't mention this before, but the distribution layer is sometimes referred to as the aggregation layer. Let me highlight that. That's the worst highlighter ever. Better. Okay. But it does things like route filtering, inter-VLAN routing, management ACLs, IPS, security policies, routing, because remember they are layer 3, and then summarization and next hop redundancy. I said a lot of words that we have not covered yet. We will. Just know that those are the roles that the distribution layer typically has, or the ones we give to it. Now, there is something I skipped over. You may have noticed this. Because the distribution layer is the intermediary between the access layer and the core layer. What's the core layer? I didn't talk about the core layer.
Yeah.
Well, if I scroll up just a little bit, look at this. There's another layer? What? What is
That's
that?
the
We'll talk about that.
router.
Right now, we're only looking at the distribution layer and access layer, which is called the two-tier architecture. And we'll touch on it here in a moment. Now, let's talk about these other single points of failure. How can we fix things? Well, we can add more devices, right? Like, check this out. I can add one more distribution layer switch. Let me do that. Scoot him over right here, and we'll connect our switches, so it might look like this. We'll add one more connection, one more connection, one more connection. Then, of course, we'll connect our switch to the router, and then we'll even connect our two switches to each other. This is what I'm talking about. We've got two distribution layer switches, no longer a single point of failure. We've got two links to each switch. That's amazing. And then we have two connections to our router. But wait, hold on. We still have one router.
Yeah.
Can we solve that? Let's solve that right now. Let's put in one more router, and we'll connect both switches to them. Man, look at all that redundancy. It's beautiful. But it's expensive. This is ideal.
Yeah,
companies
that's...
aren't willing to pay that.
Just thinking how much switches and routers you need. And then, even with the internet, you have to get internet from two internet providers.
That much for stuff, because
That's
these
two
my
modems.
gosh, these layer 3 switches, they could be like hundreds of thousands of dollars. Same for the routers, just depending on how big you go. No one said networking is cheap, which is why we make the big bucks. Now, this two-tier architecture isn't the only kid on the block. And let me show you where a three-tier architecture might come into play. Let's say Network Chuck Coffee really just starts booming, like, oh my gosh. And we have to add more buildings just to hold all our people. We have so many people now. Now we have 3 buildings. Things are booming. It's amazing. But we need to connect our buildings together so we can all, have a network. That's what we're doing here, right? All right, let's connect them. So I'll connect my multi-layer switch to my multi-layer switch down here, my distribution layer.
Why
Same
would you do
thing.
that?
Let's go over here and let's do it right here. Just random, but hey, we got connectivity, right? But let's make sure we add in some redundancy. We'll also add redundant links. Make sure each switch has a connection to each switch, and each location has a connection to each location. Okay, we did it. It's kind of a mess, but we did it. We have a new building coming in. Okay, get ready, guys. I gotta hire some more network engineers. All right, so let's connect them. Here we go. Okay, this is getting a little crazy. As big as our distribution switches are, they're under fire right now. They can't handle all this stuff. Too many connections. They're running out of ports. We're maxing out the bandwidth. What do? Let's go with a 3-tier architecture. You saw that coming, right? Let's do it. Get all those connections out of there. Whew, stressing me out. We're gonna add one more layer here. So let's get our routers out of here. Or scoot it up. We're not going to get rid of them. And we'll put our next layer in. And this layer will have a beast of a switch. It will also be a layer 3 switch, but this will be the big daddy. He'll be so powerful, so awesome. He can handle all that traffic. This switch is our core switch, and this is our core layer, tier 3. Our distribution layer switches will connect up to him. In a perfect world, we'd have 2 of our core, because he's the main guy. And we connect them up, and our cores will be connected to each other, and then we'll connect our routers to our core switches. This is a beautiful, lovely campus network design. Oh, so good. Expensive, but good. Okay, now what's this core layer doing besides just being awesome and powerful and huge and Let me show you. Let's go look at Boson. So the access layer, we know he's connecting our devices, our phones, our computers, everything. He's the access layer. Distribution, we just talked about him. Now the core layer, what is he doing? Look how short his paragraph is. That is truly sums it up here. He's like that massive guy at the gym, just over there, is grunting. That's all he does is grunt and lift. That's what this guy does. He's just fast, and he's associated with low latency and high reliability. So the core switch is...
Basically, he is the biggest switch there is that you can imagine.
Expensive, reliable, and beefy. Because he is the network backbone and a ton of traffic goes through him, he has to be able to handle a lot. The weight of the network's on his shoulders. So this is our Cisco 3-tier network design model. Core, distribution, access. Now I want to talk real quick about the 2-tier. The 2-tier had the core layer gone. But no, hold on. He wasn't gone. He was still there. Or his role was still there.
It just was the router
the job
itself.
Of the distribution layer. Let me show you real quick. I'm going to scroll down through Boson's amazing courseware and get to the Cisco 2-tier network design model. Notice what they call it, the collapsed core layer. This model is often referred to as the collapsed core model. I don't know what happened to my D there, just ignore him. But the functions of the core were collapsed into the distribution layer. So the distribution switches have all the responsibilities of the distribution switches, right? They have to do a bunch of the routing, the inter-VLAN routing, access control lists and such. Like they do a lot. And then they have to also be the backbone of the network. They have to be powerful and crazy, which in most cases is A-okay and fine. I've seen more collapsed core or 2-tier models than I've seen 3-tier. 3-tier is fantastic for what I'm about to show you right now. Looking back at our 4 buildings here, here's our new design with a tier 3. Notice that only one of the buildings has the core layer, the tier 3 layer, and that's the design, right? The core layer is the core for the entire campus. So now you can imagine how this might simplify things. Our distribution layers will connect back to our core layers, but just to the core layers, not to each other, with that full nasty mesh like we had before. This allows us to scale a lot easier if we have a massive campus. So this is a bit better. My drawings are horrible. Let me show you a better view from Cisco's perspective. Cisco has great documentation. Here's how buildings will connect without a core. We just saw this. It's so not scalable, right? It's too complex. But if you scroll down just a little bit, here's our core, and it solves a problem. It's beautiful. A lot more clean. We have our one core, and then we have all our tier 1 and tier 2s in our buildings. Now, you want to see a core switch and how big it might be? Looking back at Cisco's available distribution and core switches, that's what this is called. Find the best core and distribution switch for you. If you are on the far right, it's the smaller stuff. If you go to the very far left, you get bigger and bigger and bigger until you get to the big daddy, the Cisco Catalyst 9600 series. This thing's a beast.
25 terabits per second. Holy fuck, that's a lot.
They're modular, so you can just slide in extra little features and awesomeness. They've got redundant everything. And look at the available backplane or bandwidth it has, 25.6 terabits per second. It's pretty crazy. If you want to see one of these, actually, David Bombal and I went to Cisco headquarters in San Jose, and we got to talk with the guys who designed it. They walked us through it, so I got a video below if you want to check that out. Actually, I'll play a clip right now.
Free file, dude.
Oh, yeah.
That's nice.
That feels high quality.
That's nice.
Wow.
You see that they are hefty, and so that's also another future-proof for delivering power.
They had just released it, and they let us take a look at it and play with it. Crazy. Now, as I mentioned
It
before,
is crazy.
this model right here is the one I've seen the most of. It's what I've worked with the most. The collapsed core, where you have your access layer doing its thing on both sets of designs. But then you have your collapsed core. The distribution switches also being the core switches, and then these switches will connect up to your routers. When we're looking at tier 3, I love looking back at that Cisco example. This is why you want to have a tier 3. When you have a bunch of buildings in a campus that all need crazy high-speed connection to each other like they're all in the same building. So we call it a campus, and really where we got the term from is like a college campus, a school campus. Yes. I went to Cisco's campus, and they have like a bajillion buildings. I got lost multiple times, and they have stuff like this. I mean, they invented it, right? So they invented it because they probably needed it. But what I found is most companies I've worked for, we have one main corporate office, and we had our core distribution switches connecting to our access switches, and that's all we needed. Now that's just the campus. That's connecting our people and our users in the same building. We have more than that though. We also have data centers and how we design our data centers. We have cloud and how we design our connections to the cloud.
But that's again different.
We have our small office, home office. We have our users, all kinds
home
of
labs.
We're going to talk about all those here in the next few episodes. Now I've got some homework for you. Here's what I want you to do. Most of you work for a company, right? You may be in their IT department. You may not be in their IT department. Doesn't matter. What I want you to do is find out what design they have. Is it 2-tier? Is it 3-tier? Is it some weird tier? I don't know. Find that out and let us know in the comments below. I think that'd be really fun to see everyone's design and their network. And that was...
Let's see what people said about this. Thanks to this, my home network is more expensive. No. Of to feed a small home business network for 40 million. I went with Cisco small business equipment for my home and I thought it was overheated. My internet access can automatically fail over from 1 gig cable to 4 gig wireless. This video makes me feel nothing. For home network, I need to log into mesh networking. In theory, every device has connection to every other device, which is good for failover, but is Wi-Fi only. Yeah. See, as long as it works there. Good that I don't have a bug. So don't buy a pug when you're running a coffee shop. I don't know how to taste. My networks go with the boat. Come on, the Burger is getting super high tech. They just order 30 tickets and 50 feet long of string.
Let me know what you think. Comments below. If you have any questions or
amazing,
let me know. Or if you need help, let me know as well. And by the way, did you know I have a Discord community? Discord's a place where you can go and get help.
But I think I'm gonna stop here with the learning and instead switch to, well, something else. What time is it? Maybe some gaming, something else. Yeah, why not? There is a game I wanted to try out. I'm gonna stop the YouTube stream because I don't want to muck it up. So this was technology, not that. That's fine. And I'm gonna stop here. And for YouTube viewers, thank you for being here. Thank you for watching. Have a nice day. Post this.